Welcome everyone to our paper, Upgrading Search Applications in the Era of LLM, Case Study and Practical Lesson.
The National Library has a very strong motivation to improve user search experience on the Web Archive. Since 1996, the National Library and their state partners have been archiving web pages. These were initially done as curated crawls and harvests, but then whole domain harvests were added with the .au domain. Last year alone, over 2 billion files containing 160 terabytes were added. That's 60 files a second, 24/7. In 2019, the new search interface was added to the NLA's Trove search. There's keyword search and PageRank search over this web archive. But keyword searching is no longer adequate. The public expect search engines to implement semantic searching so they can search for synonyms and concepts. So the National Library's questions were, what are some efficient ways to add semantic search capabilities to such a massive text corpus growing so quickly? How can we help users understand why documents appearing in search results were chosen? And finally, how can we help users continue their exploration of the Web Archive?
Hello, this is Jaideep, and I'm going to take you through both the different approaches we have tried to upgrade NLA. One is reranked NLA, another is neural NLA. Now, the similarities between both these architectures are colored in blue boxes, whereas the major differences are colored in purple boxes. In reranked NLA, we actually try to build on top of the existing search capability inbuilt in NLA, which is Solr search. But we judiciously chose to apply large language models or neural retriever models as and when necessary. We take the query from the user. We first apply Llama 2, which is a large language model, to do a keyword extraction. This is important because we want to make sure that the retrieved document indeed matches the keywords or entities mentioned in the query. But Solr search only relies on lexical overlaps or keyword matches. This is where neural reranker comes handy. Neural reranker really tries to understand the complete query intent. We use Colbert, which is a state-of-the-art neural retriever, and it uses contextual embeddings to really understand the meanings beyond the keyword overlaps. It takes the retrieved document from Solr search. We retrieved 50 documents, and it further tries to re-rank those documents such that the documents which matches the query intent comes on top. We take top 10 re-ranked document from the neural re-ranker, and it goes via deduplication, where documents which are same in content but was crawled multiple times gets removed. The result docs goes to Llama 2 again for summarization, where it makes it easy for the user to really understand the results. And also Llama 2 generates follow-up question that helps user to navigate the web archive better. Unlike re-ranker NLA, where neural models are getting used as re-ranker, in neural NLA we try to use neural models as an end-to-end retriever. To do that, we chose All-Mini-LM as our text-to-embedding model, which, given a text, basically encodes that into an embedding vector. In neural NLA, we need to store embedding vectors and search against billions of embedding vectors, which is much more expensive than maintaining an inverted index. We chose Milvus as our dedicated vector DB. In neural NLA, given a query, the query is first encoded into a query embedding vector, which is then searched against document embedding vectors, which is indexed by Milvus, and Milvus returns retrieved documents which are relevant to the query, where rest of the pipeline remains same. It is important to note here, we have used the large language models or the text to embedding models out of the box here so as not to incur huge training cost, and this is also in sync with our original plan, where we want to test how the state-of-the-art models perform when we try to upgrade search applications such as NLA.
Here is a demonstration of our application with the re-ranked NLA pattern. First, we submit a query saying, when did the NRA become the APVMA? And in the application, we generate an answer and shows the answer based on the retrieved document. You can see the retrieved documents and also a summary of each document. And at the end of the application, we have the follow-up questions. And once you have reviewed that question, you can go and submit a new question. And we will retrieve the relevant information.
So this is the evaluation application which we provided to 14 people from the National Library for Australia, so that they can assess how our search patterns, our search methods performed against the baseline. And then we had the two search patterns we provided using LLMs, the re-ranked NLA and the neural NLA. You have the relevancy of query results that we provided an evaluation for through these slide bars which the slider just simply allows the evaluator to then decide whether they thought that the summary provided through the LLM augmentation was helpful. In terms of the follow-up questions, they would be situated at the very bottom of each column. 3 follow-up questions are provided, which can guide the search end user to further drill down into what they're looking for. And again, we provide a slider so that the end user can decide, the evaluator rather, can decide whether the follow-up questions are helpful. In total, we went through 49 questions.
In terms of the summaries displayed in re-ranked NLA and neural NLA, in re-ranked NLA, the summaries are answers generated by the large language model with respect to the query. So it tells the user whether the answer is in this website and what is not in this website. For the neural NLA, this summary is basically the original text, the original snippet in the vector database. So when the user ranks whether the summary helps them to make the judgment of whether they will click on the website, we are comparing which one is more helpful, the original snippet or a answer generated by the LLM. So this is an example that ranked NLA and neural NLA both come up with the right answer. For this question, ranked NLA have retrieved higher quality results. As you can see, the answers is more accurate. If you click on the first result on this re-ranked NLA, it tells you exactly the answer, and this is this is exactly the result that you want. While if you click on the neural NLA, you can already tell from the snippet it's not very high quality. For this question, we ask who are the members of FERB, which is an Australian organization. In the neural NLA and baseline NLA, none of them were able to give a good answer. However, because in re-ranked NLA, we have a multi-step question answer generation. So the final answer large language model is able to compile a timeline from the answers that are retrieved throughout different times. So this is another example of where NRA in Australia is National Registration Authority for Agriculture and Veterinary Chemicals. It is not the National Rifle Association as the neural NLA think it is. This is because the embedding model we used for neural NLA encodes NLA as the National Rifle Association, while our Solar search in re-ranked NLA is able to pick up the real NLA in the article as keywords. So the re-ranked NLA is better at recognizing the Australian specific entities because it does the keyword search. That's why the re-ranked NLA is able to get the right answer.
If we look at the empirical results, when we consider the NDCG metric, both approaches have better results compared to the baseline. So this means retrieving relevant results and ranking it in the right order. Re-ranked NLA and neural NLA has done a good job. When we look at the other matrices, re-ranked NLA has done much better compared to the baseline. In some of these other matrices, neural NLA is similar to the baseline. What was the percentage of queries returned relevant in the baseline versus our two approaches? In re-ranked NLA, we were able to answer 65% of the questions. In neural NLA, we were able to answer 63% of the questions. So what was the percentage of evaluations reported to have helpful result summaries? In re-ranked NLA, 52% of the users found them to be useful. With neural NLA, 18% found the snippets to be useful. So this indicates that users prefer summaries over snippets, and the LLM generated summaries were useful. What was the percentage of evaluations reported helpful for follow-up questions? In re-ranked NLA, 55% found the follow-up questions to be relevant. In neural NLA, 38% found the follow-up questions to be relevant. A key insight we have here is users found the new capability of follow-up questions helpful in discovering additional information related to their original queries.